Okay, so let me prove that 1 is equal to 0.9 periodic in the most sophisticated way possible by considering the construction of the reals as equivalence classes of Cauchy sequences of rational numbers, and proving that the class that corresponds to 1.000 and the class that corresponds to 0.9 periodic are actually equivalent Cauchy sequences, and therefore they are the same real number. Is that rigorous enough for you? First of all, here's the definition of equivalence classes of Cauchy sequences. If we have a Cauchy sequence an and another bn, we say that they are equivalent if for all epsilon, a rational number, a positive rational number, there is a natural number n, such that for every little n bigger than n, the difference between terms in the sequence is less than epsilon. So they are arbitrarily close together. So what are the two Cauchy sequences we're going to compare? One, there is an, which is just the sequence that is all ones. Every term in the sequence is a 1. And second, I want a sequence that converges to 0.9 periodic. So for example, the 0.9, 0.99, 0.39s, and 0.49s, etc. That converges to the infinite decimal 0.9 periodic. And by the way, the general term of that sequence is a sum from k1 up to n of 9 divided by 10 to the k. So that's the general term. And we want to see if these two sequences are Cauchy equivalent. So to prove that those two sequences are Cauchy equivalent, let epsilon be bigger than 0, and we want to find a little n such that if it's big enough, then this difference will be less than epsilon. So let me first compute what this is. This is the difference of 1 minus the generic term bn. And that difference, if you're looking here, 0.9, 1 minus 0.9 is 0.1, 1 minus that is 0.01, etc. So this difference is just 1 over 10 to the n. And we want that to be less than epsilon, so 10 to the minus n is less than epsilon, when minus n is less than the logarithm in base 10 of epsilon. So if we take capital N to be the greatest integer below the logarithm in base 10 of epsilon, then for n bigger than that, we do have that an minus bn is less than epsilon, and therefore those sequences are Cauchy equivalent, and therefore 1 and 0.9 periodic are the same real number from the point of view of Cauchy sequences.